All right, welcome back everyone. Devarshi here. Well, in this video, in the last few videos, we have seen these 8 things. In this video, we'll see how to distribute our package with the Python package index so that our package can be installed using pip install our package name. So for this one, I have taken the same thing. We are not using the this UV demo that we have used. Okay, let's abandon this. Remove recursive bytecode.env. By the way, time to time, remove these virtual environments wherever you create because they consume a lot of space and it can sometimes it can consume 1 GB depending on the size of the packages you install. Okay, cool. Let me go back here. Okay, so we have a package here in the pyproject.toml. I have named the package as db demo project, this one. Let me remove all the dependencies here. Okay, my project doesn't have any dependencies. Okay, maybe one dependency uv add rich, say uv sync. Let me, okay, removed all the things. I want to add only one dependency, let's say rich library. Don't go get into the details of what is a rich library because we don't want it. I'm just taking an example. Even I don't know what is rich, but yeah, it is used for printing colorfully in the terminal. You have, I'm sorry. Okay, pyproject.terminal. You have the dependencies rich. I'm leaving the author section blank. This is a demo project. Let's name this as version 0.1.1. We have the source distribution. I hope you have read about source distribution and wheel distribution. I'm not going to explain to you here. And I want everything. Let's say everything is in the package src, package 1, package 2, package 3, package 4, package 5 to get exported, to get what do you say this? Like this one, to be able to I want these 5 packages to get into the side packages like this. So side packages folder when installed using pip install, and the user can directly use this one. Okay, from anywhere here you can do import from package 1, from package 1 you can import module 1, something like this. Okay, let me delete this. So you'll be able to do. Okay, now configure what should get exported. Now I don't want to export the, like, I don't want to install src package. Instead I want to individually install all the 5 packages. Hence I have written like this. You can experiment with different kinds of syntax. Go to ChatGPT, ask it to make you practice different kinds of different ways of writing this. Include SR sources so that you will be able to gain a knowledge on how to make the packages accessible through the side packages when installed using pip. Okay. Yes, I don't want tests to get exposed. I don't want docs. I don't want VNV. I only want these 5 to be accessible in the distribution file. Okay. How to make so the first step in distributing our project, let's say this is s4.txt. So in the first step to distributing package, the first one is to build a distribution file. You have to build your project. How do you do this? You write uv build this. If you are using uv, just write uv build. UV build, this command will go and look into your pyproject.toml and look into the build information and it will build you. UV build. Okay. We see a dist folder here, this one, and we see 2 things. First one, let me extract it. First one is a wheel file. The second one is tar.cz. What you see here, that tar.cz file, it is also a zip file. Tar is a different way of zipping. This is the proper zip file. Okay, this is a build distribution, this is a source distribution. Let's see what's in it. Okay, we can see the contents using by unzipping them. Let's write unzip dash l. This is, I'm just want to list all the files in the zip file. Copy this part and write. No. You see, this wheel distribution has package 1, package 2, package 3, something along these lines. And you have all the, this is metadata of the project. Second, we see that all 5 packages got are accessible inside it. And this is a wheel file. Another one, let's try to look at the contents of it. But this, by the way, tar only accepts Linux style paths. So I'm writing this slash db demo project 0.1.tar.z. Okay. Now you see here it packed our project exactly as we specified. No, I told, hey, include everything inside the SRC. By the way, let me tell you, this wheel file is built after making the source distribution. If you strip away the path directly here by including sources is equals to SRC, you will run into errors. Don't do this, because when you strip away this, there will be nothing to look at in the SRC slash. It will be first one, the wheel distribution is built from the source distribution. This is not like a separate one. Okay. Now you must don't strip away the SRC in the wheel file in the source distribution itself. Don't do this. Next one. Now you have this. Okay. Fine. Okay. Now we can upload this to Python package index. So it's the same package, you can list all the files. It's like these two are only zip files, okay? Don't get confused on that. These are not some special binaries, nothing. These are only zip files, neatly packed in a format, which is in a file format. That file can be distributed via pip or via Python package index. Now, just a bit of experimentation. Let me delete this wheel file, and you can upload this. You have to upload this, write uvx uv publish. Let me tell you, this command won't work on your computer directly, okay? Because you must have an account on Python package index. I have just created an account a day before. Let me log in. You must have an account. Second, you authenticate with an app. Oh, okay. Let me authenticate it. One minute. Where is the authenticator app? Okay. One moment. Skip. Okay. No. 686 686 Okay. You notice that you are attempting to log in from a newly or unrecognized device. So let me pause the video for a minute. Fine. I've got here. Okay, you must have an account. Second, you must authenticate your account using your Gmail. Then you have to set up some tokens. All of that. It's not needed for now, but to show you, I have to do all of this. You must set an token here. Let me show you. No, uvx. When I run this command, uvx publish, it will automatically read a token file that is stored at Let me show you that .py path. So in this file, I have stored a token that authenticates this my account. So then I will be able to publish this package to my Python package index account. Uh, I should let me extend this. You, I cannot expose the whole token because can do. You see this one. Let me enlarge it. Okay. Do you see this here? This is the content of this file. Okay, this is located at my home directory .p with the file name .pirc. You have to set up a username for this kind of token. You can get this token from your account. Okay, you have to set this kind of thing. Then only you'll be able to execute that command. Let me clear it. Are you able to see the token? No, the full token is not visible. I'm safe. Here. Okay. Cool. Let me verify it again. Okay. Let me downscale my video. Okay. Right. Okay. Now let's do this. UVX UV publish. Now this automatically picks the token that I have showed you right now, and it publishes this package. It looks into the distribution, and it pushes this to the Python package index. So you see, we were able to upload this to this Python package index platform. Now you will be able to install this. Let me open a just okay, this one. Let me create a random folder in the downloads. Let me create it. Okay, UV demo install package. Okay, Control Shift C, new window, open this folder. Okay, good. Now let's see if we can install this. UV okay, now you see in my account we were able to push this project. Okay, DB demo project. DB refers to Devarshi Balu because I don't want to pollute the global naming, because whatever name you enter here, that should be a proper name, and that shouldn't conflict with any other packages that PyPI hosts. So that's why I have prefixed it with my name so that I won't corrupt the global namespace. Okay, let's and you can see that we have pushed one release version 0.1.1, and let's see if we can install this. Let me create a UV virtual environment. UV and okay. Let's create some random folder. Let's py and let's install UV pip install DB demo. It's trying to activate. Okay, let's install UV pip install. So what was the name of our project? DB demo project. This one. By the way, while installing this, replace the hyphens with the underscore. You see, it has installed our DB demo project. We were able to push it to the Python package index. We have successfully distributed this one. Then it installed all of this. You can see that in packages, side packages. You see, package 1 is here, package 2 is here, package 3 and 4, 5 are here. And I also mentioned that rich is the dependency of it. Dist info, we can see it in the db project.demo and field file record metadata. Yeah, it's requires a distribution rich, this one. It also installed it, since rich depends on markdown at py md or pigments. It also installed those three packages. Okay, now we are able to do this. Now I did a strange thing last time. Okay, I haven't I have deleted the wheel file. Let's build it again. Okay, now this time I will increase the version number by 1, because if you don't increase the version number, then it will then UA will reject, sorry, Python package index will reject it. Let me build the project again. So this, I told you, right? They gave some build tools. You build the project using build command, UV build command. It has built the project. Let's publish it. UV publish. Okay. Hmm. Okay. Fine. I think it updated the same. Okay. Now let me update this version number. Let's build a different one. So UV build. UV publish. I'm publishing a different version now. Okay. Now I delete this and I build it again. UV build. Say it is cross it by upload file by request. Okay. This is what I wanted to show you earlier, because whenever you make changes and you want to push that change again, ensure that you increase the version number, because if you push it with the same version number with a different change, it won't accept. Okay, then let's do it. I'm pushing it again. What's happened? Okay, let's delete all of this. And I want to, sorry, UV build it and UVX publish. Okay, now come back here, this one. Now I want to install UV pip install upgrade package db demo project. Now the latest version is 0.3. Okay, let me delete it. Let's create a UV virtual environment and UV pip install db demo project. Oh, it's still accessing the this one. Let me delete the package again. UV pip and install db demo project. Now install it again. Now I want you to, this is the exact one. I want you to notice one difference. Here it built the project, but here it is not building the project, it is directly installing it. We can see it through the command prompt again. Let's try to install it in our global Python interpreter. Pip install. Don't, while working with the this one, global Python, I'm not using UV. pip install db demo project. Let's do this demo project. It will install okay, it is installing the latest version 0.3. Okay, do you see one thing? It is not building the project. Why? Because it directly found the wheel file. Wheel file is the last one, the last product that you get after the building. So first time when I directly only push the source distribution, it has to pull the package, then build it again, then install it. Now it directly install the package. Okay, and we can see it. Let's go to it will show it here. Okay, uv pip pip show db demo project will show us where it is located. Let's go to this location and see. Paste the path. Now you see here we'll have package 1, package 2, package 3 listed. This one 1, 2, 3. You see here we were able to distribute our package, and now the user can directly access this from the imports. Okay, let's delete. Let me delete it. Okay, now we are good to. Now let's revisit our definition of distribution packages and libraries again. So before that, let me explain you what actually happens when you do pip install. Let me go to my Razor file. Okay. Okay, here it is. So whenever you write pip install something, let's say you're installing pip numpy, pip install numpy. First, your package manager looks for it, looks into it in the Python package index, checks for the numpy package with the specified version. You can also specify, hey, I want to install only a specific version. Let us say it is 2.5.2. I want to install. Okay, with the specified version, the package manager looks inside the Python package index repositories and looks for this version. Then, if it finds a wheel distribution, then it will directly install it. If it finds a source distribution and an absent and the wheel distribution is absent, then it will construct the wheel distribution from the source distribution, because in the source distribution, if you remember, we'll also have pyproject.toml inside the source distribution. From that pyproject.toml, it will get the build information of the project. It will know how to build the project. So this package manager will build the wheel distribution, just as happened here. I guess here. Okay, it builds it like this, then installs the package. Next, it extracts the packages from the wheel file. You saw this. These packages, we see this one. Let me unzip it, copy, unzip this slash unzip myself db dot no dot p sorry it's py3. Okay, then whatever it finds the package, apart from this metadata, it will store in a different file. So these things, by the way, this is also it will paste all these packages inside your side packages folder. This side packages folder. If it's a virtual environment, it will paste that in the side packages folder. If it's a global Python, then it will place there. Next, since the side packages is in the Python path, you will be able to use those. You will be able to import those from import statements. Then alongside, we also saw that package managers install all the dependencies of the package. Okay, and yes, we were able to solve the problem that we were discussing. Yeah, this one. We were able to solve the problem with the Python package manager. Okay. Next one. Yeah, let me go. Okay. Okay, let's have a quick revision. Whenever you specify a package with a particular version number, the package manager goes and looks in the Python package index. If it finds the source distribution, it builds the wheel distribution itself, then extracts the packages and places it in side packages. Or else, also alongside, it installs all the dependencies of the package that you have installed. Okay. Now let's define the library distribution again. Okay. Okay. Fine. Okay. Cool. All right. Something up. Fine. Fine. So what is it like? Module package? No. Package is literally a directory containing all the modules, a certain set of modules. Then the package can have multiple packages nested in it. Then what is a library? A very generic term, a collection of code written by someone else or even by you, but not native. It is not natively a part of your main program. You are bringing it from somewhere else. Okay, that's a library. Very generic term. It's a bunch of code that's not a part of your program, and you're bringing it inside your main program from somewhere else. What's a distribution? It's a your Python project, your Python project code neatly packed in a file format, which can be distributed through, Python package index. Cool. Fine. Now let me answer the question. Why do we interchangeably use the package, library, anything? Sometimes we are installing pandas package or numpy package. Sometimes we call it, hey, I'm installing the numpy library. I'm using the numpy library. Why? See, I think both are justifiable. Okay, if you are saying it is a package, okay, don't you think it's a package? It's a package. In fact, it's a package. So what is a package literally? It's a package, a directory containing modules inside it. And NumPy, if we look into this one, let's say we install NumPy here. We pip install NumPy. Okay, it has installed NumPy here. The NumPy distribution numpy.libs. Okay, this is actually a package containing so many modules, so many nested packages inside it. You can call it as a package. Yes, it's a package. Even if it's installed, even if pip install NumPy, this distribution installs 4 or 5 different packages. They are still packages because they contain the Python modules. No, why do we call it a library then? We call it as a package because it's a directory containing folders. Now, why do we call it as a library? I said that library is a very generic term, and it's a collection of code. It's a collection of code that you bring into your main program, and it could be written by someone else or maybe you, but not natively. It is not natively a part of your program. So that library can contain modules, packages, classes, functions, etc. inside them. And even if you just install, if you call it, it is justifiable to call it a library. Why? Because it's a bunch of code again. It's a collection of code that you are bringing from somewhere else. And that's why package and library are used interchangeably. But yes, you should know the literal meaning of this. It's okay to call it a library because it's a collection of code written by someone else and you're bringing into your program. It's a package, yeah, because it's a package. When you install NumPy, it install when you install see NumPy, it installs some packages into your side packages, and you'll be able to install it. Let us say I install open pandas. Oh, I have to use evpip to install pandas. Now it install pandas. So it's again a package containing multiple packages, and you can call it as a project also, and you can call it as a distribution as well, because it is a distribution. It is in a distributable format. So you cannot directly call it a distribution, but yes, these two comes from this distribution, and your package manager extract these packages or the library contents from these packages. A quick wrap up to the library. By the way, a library can contain many packages inside it. Okay, and that's it. Uh, Wait a minute. Okay, let me tell you one more thing. Okay, let us say uh, you have a GitHub project and you want to install that project as a package inside the side packages in your virtual environment. Let's see how do we do that. Okay, where is docs? This builder distributing. Okay, let's install one more. Let's add one more thing. Installing package from the with GitHub link. Okay, let us say I have a project. Maybe let me install. Okay, I'll install in this one. Okay. Currently, it has so many things. Let me personally remove this virtual environment .env. Okay, now let us say I want to install a package, a project as a package. GitHub.com. There is a project ml455 devs slash mapc. ML4 Wi-Fi devs. Okay. Okay. Yeah. Let's say I want to install this project as a package. Okay. How would I do this? First, copy the GitHub link, HTTPS link. Then with UV, right? I was here. Okay. Then write UV pip install this one. If you directly paste the HTTPS link, it will raise an error. Tell it, hey, git, this is git folder. Add git plus in front of it. Oh, sorry. I forgot to create a virtual environment. Let me activate it. .env script activate. Now, let me run this command again. UV pip install git. Now it goes and checks this folder, resolves all the. So I'm telling it because you will use it in future at some point. It looked into the package. It has installed everything, even this one mapc mab. It installed this as an editable. Okay. Okay, from Git. And you see that there is a particular commit hash here. This is the most recent commit of that. You see 293. Let me copy the commit hash. No, index.data. You see, this and this are equal. Like it has built the project from the most recent commit. Let us say you want to build the project, or you want to install a project as a package from a particular commit hash. Maybe let me go here to say I want to install here at this point, at this commit hash. What we can do, let uv pip install. I'm coming here again. Okay, we can do this one. uv pip install git plus https the github link github.com slash ml4 wi-fi dash mapc mab add this commit hash. So now it went to that location and it is installing the project at that particular commit hash. Okay, yes, you see that it has removed the latest one it installed at that particular commit hash. Okay, this is a very useful thing. We'll use this in the future. Okay, and yeah, let me finish this with one last thing. How do we set up a project locally in Python? Okay, let us say okay, this one, let me take this one. Okay, let us say I have mapc base here. I want to set this project locally. How do I do this? First, you can by the way, if you receive the file in a zip file, you'll be able to figure out it through this process. Let's say I'm cloning the file from the GitHub. Okay, I'm coming here, delete permanently. Okay, so first git clone that package. I want to clone this. So it has cloned. Change to that directory in pcdcf. Okay. Now create a virtual environment here. By the way, now once you got here, we will not create virtual environment now using uv create a virtual environment then install all the packages, nothing. We will use a very shortcut way. Write uv sync. What will this do? Next, also install the editable current package as in an editable mode. What will this do? This uv sync first looks at the pyproject.toml. It figures out the version of the project that is currently that is required. Then it looks at the dependencies, install all those dependencies, and creates a uv.log file. Then it will build the file and installs the current package as a editable in an editable mode. Sorry. Okay, have you forgotten to no? Okay, UV sync editable. Hey, I think something went wrong. Actually, env this .env doesn't match the environment pop-up. It will be ignored. Target the environment instead. Where did it install, by the way? Downloads. Oh, PCDC. Wait, show. PC. What happened? Where is it currently located? Oh, I have a .vn. Okay, it automatically, no, nothing went wrong. Okay, it automatically created a virtual environment for you. With the Python version, you can see uv run Python version. With the version. Hey, let's activate virtual environment. uv source .venv slash so that we get rid of the server. Scripts slash activate. No, yeah. Now uv pip uv run Python version. You see that we have installed Python 13.5. This you see here the pnv scripts python.exe. This is the executable. You can execute it directly. Okay, let me do this one. Oops. Install the code slash. Let me copy. Okay. Okay. So this is the Python and you can do it. And you see this is just as writing Python because I have mentioned the executable path explicitly here. Okay, this is of the version 3.13.5, which is satisfied by requires Python. Then it installed all the dependencies. You see it here. Okay. Then it installed the package in an editable mode. Have you run UV sync editable? I project dot settings. Okay. Settings. Okay. This line. I haven't saved the file. That's why we written error. No, you UV sync editable. That's it. You have now set up the project. This is very easy. And okay. So this is a project which doesn't have uv.log. Let us say you want to set up the project uh, which has uv.log. Then again, let's delete the virtual environment. Deactivate it. Then just type uv sync. It automatically, by the way, UV sync editability. Okay, it automatically installs the. I hope you remember the version locking that we discussed earlier. So it automatically installs everything for you. That's it, and yeah, that's how you set up a project. So if you want, let's see another one. Let us say, let me take this one, github.com slash sorry so let's try to install this. Let me clone this. So this project I'm trying to set up locally. Yes, continue. Yeah, where does it go? I think here. Okay. Done. Delete permanently. Okay. Now, let's say I want to first git clone it. So no such file or directory. What happened? HTTPS this one. Git clone GitHub. Do not find sensor when. What happened? Oh, why isn't it able to clone this repo? So I want to clone this repo. Do not need open this. No such file or directory. What happened? Something is up. Let me close the VS Code, run it again. File, open folder. In the downloads I created, remove them and install. Okay. Okay, now I refreshed the window. So, okay, change to this directory, srmabmlo. Then, okay, what you have to do, go on packages.txt. This is a very bad way. Shouldn't do this. We need not to install this. Let's see pyproject.toml. Yeah, it is everything fine. It uses a different build system. Okay, this is also fine. Just type uv this UV sync. It will automatically create the virtual environment for you, looks into the pyproject.toml, installs all the dependencies, then locks those versions. At last, it will build your project as a wheel file and installs in the virtual environment. And yes, we were able to set up the project in a single click. And if you want to run any file, just go and run it. Will be able to run it. Say I want to run maybe any file. Say, what is it here? Do I have anything in test? Yes, this test scenario. Let's say I want to run this. Run in the interactive window. Predicting kernel. Choose a kernel. Let's choose our interpreter. Python environments. The current project, this one. No, CSR maybe MLO, right? Select another kernel, Python environment. Where is it? CSR maybe MLO. Yeah. Yeah, this one. Okay. Nice. Select a kernel to run this. Okay, this one. Now let's run this file. Yeah, as I said, it needs this notebook kind of. If you want to run your Python file in a notebook, it needs some packages. Let it install. It will automatically install those packages. Okay, and I hope you installed everything that I mentioned here. Devarshi.Balu.Notion.site. And I think Python prereq software, this one. And I believe that you have installed everything that I have said here. Okay, install them, otherwise you won't be able to run this probably. Yep. Yep. Yeah, it's running this file. Yeah. Yep. I think yes. While it installs, let's check our progress. Yes, it's s3.txt. Yes, we distribute. We were successfully able. We have seen how to distribute our project through the Python package index, and that tokens thing you can figure it on your own. Search in the internet and just know how to set up the token inside your working the home folder. Then install a package with a GitHub link, then be setting up a project locally using Q. And yes, yeah, this file ran successfully. You can run any file, by the way. You can run any file. Looks like there are some problems. Or the problem argument of type. Okay, these are typing errors, not the. Okay. Fine. You can run any file. If you want to run any file, just go there and. Say agent simulations, you want to run this, just run this, click this, and you will see it running. So this is how you set up a project locally in Python. And yeah, that wraps up the series. And we'll see. Let's wait for this file to finish, okay? And we'll wrap up the video. And you see that yeah, it's progressing well, and it will eventually finish. This is gonna take too much time. Not too much time. It will finish in a few minutes. Hmm. And yes, you see all the files here. Now, I hope you have worked with matplotlib sometime before. Now, if you run this file from the CLI, you understand how your situation gonna be. 10 different windows pop up, and you'll find yourself juggling between multiple windows and trying to interpret something. Okay. Now we have it's a bit more cleaner to run in this kind of notebook environments. Yes, you have everything, and that's how you run a Python file by setting up a project locally. Okay. With that, we wrap up the video, and I'll see you in the next one. Bye bye.